Hello everyone. I am Adripta Ghosh, a second year student of Electronics and Communication Engineering Department of Coachbihar Government Engineering College. Today, I am going to discuss about the basics or fundamentals of communication system of the subject analog communication. In the upcoming slides, I will discuss from the very basics of communication system. What we will learn from this presentation or what we will learn from this video? This video includes the idea about communication, the equipments of communication, what is communication system, communication channel and its types, and the mathematical model of communication. First thing that comes in our mind is communication. What is communication? What does it mean? Communication is the process of establishing connection or link between two points at some distance for information exchange. Or we can also say that it is simply the basic process of exchanging information. So, what are the equipments of communication? The communication equipments includes all the electronic communication such as diode, transistor, amplifier, oscillator, etc. The next thing is the communication system. What is communication system? What is the need of it? In the previous slide, we have gone through the different equipments of communication such as different electronic equipments, diode, transistor, rectifiers, amplifiers, etc. These such communication equipments are assembled together to form communication system. What are the example of communication system? Mobile communication, radio broadcasting, television broadcasting, cellular communication, satellite communication, radar communication, etc. are the example of communication system. For better understanding, below a block diagram is given communication system. As we know that communication is basically an information exchange from a source to its destination. So, in this block diagram, we can see that information source is supplying information to the destination through a path. In the upcoming slide, we'll discuss more about the different blocks of the communication system. Now, I am going to discuss about the different functioning of the blocks of the communication system. The first block of the communication system is information source. The information or message originates from information source. The function of information source is to produce required message which has to be transmitted to the receiver. What are the different types of information? Words, code, sound energy, video message, audio signal, etc. The next block of communication system is input transducer. Input transducer is basically a converter which converts one form of energy into another form. The input signal from the information source may or may not be electrical in nature, but we need the input signal to be electrical in nature, and input transducers assures our requirement. It ensures the message signal must be converted into time varying electrical signal. That's why it is very useful to us. The next block is transmitter. What is transmitter? What is the function of the transmitter? The function of the transmitter is to process the electrical signal from different aspects. It provides specific frequency range, amplification, modulation. And the next term come up. What is modulation? Modulation is the main function of the transmitter. In modulation, the message signal is superimposed upon the high frequency carrier signal. The next one is channel and noise. The medium through which the message signal travels from the transmitter to receiver is the channel. The function of the channel is to provide physical connection between the transmitter and the receiver. There are two types of channels, namely point-to-point channels and broadcast channel. Noise is an unwanted signal which tends to interfere with the required signal. It is introduced in the system during the process of transmission and reception, and as a result, the signal gets distorted. It is always random in character. Next block of the communication system is receiver. What are the main functions of receiver? Main function is to reproduce the message signal in electrical form from the distorted received signal. The reproduction of the original signal is accomplished by a process known as the demodulation or detection. Demodulation is the reverse process of modulation carried out in transmitter. Receiver creates or regenerates the original message signal from the distorted message signal. The next block is destination, and it is our final block. Destination is the final stage which is used to convert an electrical message signal into its original form. For example, in radio broadcasting, the destination is a loudspeaker which works as a transducer. That is, it converts the electrical signal in the form of original sound signal. The next thing we have to learn is what is bandwidth. Bandwidth is defined as the portion of the electromagnetic spectrum occupied by a signal. It can also be defined as the frequency range over which an information signal is transmitted. In simple words, it is the difference between the upper and lower frequency limits of the signal. As example, we have a music signal, then the range of the music signal is 20 Hz to 15 kHz. So the bandwidth is f2 minus f1, that is 15,000 minus 20, that is 14,980 Hz. In previous slides, we have discussed about the channel. What is a channel? Channel is basically the path or medium through which the message travels from the transmitter to receiver. So here, now we will discuss about the different types of communication channel. We'll basically discuss about the four types of channels. And the first one is telephone channel. It supports only electrical signal. Mic and speaker are used as transducer. Here, circuit switching mechanism is used. Speed signal is limited to a band from 300 to 3100 Hz. The next type of channel is optical fiber. It transports light signal from one place to another. It has core layer surrounded by cladding layer followed by thin protective jacket. Core cladding made up from pure silica and jacket from plastic. Higher bandwidth therefore can operate at higher data rates, small size and lightweight and flexible. The next one is mobile radio channel. Its major characteristics are mobility into the network, no line of sight for communication, strength and received signal varies with location. The last type of channel is satellite channel. It provides broad area coverage. These systems use satellites which are in geostationary orbit, reliable transmission link. The satellite can provide point-to-point or broadcast services. It uses frequency range between 11 GHz and 14 GHz. The last topic of our discussion is mathematical model for communication channel. So, what is the requirement of this topic? The mathematical model helps us to explore important characteristics of system like attenuation, transfer function, impedance matching, bandwidth, data rate, etc. It is used to design modulator at transmitting end and demodulator at receiving end. Types of mathematical model. Mathematical model are of three types: additive noise channel, linear noise channel, and linear time variance channel. At first, we'll discuss about the additive noise channel. What is noise? Noise is an unwanted signal which tends to interfere with the required signal, and the noise is introduced in the channel. Channel means the path or medium through which the message travels from the transmitter to receiver. What are the key points to remember about the dream noise channel? It includes almost all types of channels. It also considers some attenuation. What is attenuation? Attenuation is the reduction in the strength of a signal as it travels through a medium. So, RT, that is our received signal, is A S of t plus NT, where S of t is the input signal and NT is the noise caused in the channel and A is the attenuation factor. Our next mathematical model is linear filter channel. What is the need of linear filter channel and what are the basic characteristics of this channel? In some physical channel like wireline telephone channel, bandwidth of the input signal is important concern. To ensure specified bandwidth filters are used. With the help of filters, one input signal doesn't interfere with another signal. All such channels are presented with this mathematical model. Here, the block diagram is given of linear filter channel. Uh, Let us assume that h of t is the impulse response of the linear field. Impulse response means the response of the channel due to the impulse input. So the required signal, that is the received signal RT, will be S of t convolution with h of plus n of t. That means integration from minus infinity to infinity S of tau h of t minus tau d tau plus n of t. Our last type of mathematical model is linear time variant filter channel. In this type of mathematical model, the mathematical model is used in multiple path propagation transmission channel such as underwater acoustic channel. In this type of channel, signal undergoes different delay due to the presence of multiple paths for propagation. Here, the block diagram is given to understand clearly about the linear time variant filter channel. The received signal RT will be integration of minus infinity to infinity h of tau comma t, h of t minus tau d tau plus n of t, where n of t is the noise caused in the channel. H of tau comma t is the impulse response of the channel at time t when impulse applied at t minus tau second. Thank you.